All right. Hello, everyone. My name is Adam Jahr. If I haven't met you yet, I am the founder of Vue Mastery. We are the ultimate learning platform for Vue developers. And we have a library of content that is designed to elevate your skills so you can master your craft and become the best possible Vue developer you can be. On our platform, we have playlists arranged in different categories, so whether you're just getting started with Vue or you want to dive deeper into topics such as Pinia, Vue Router, Nuxt, etc., we have all that content available for you, taught by expert instructors, including Vue core team members, Evan Yu himself, Postva, Eduardo, and so on. And we really like to take an approach where we have a visually stimulating, animated way of teaching, and that's exactly what we're going to look at today in my talk called Rendering Revealed. Because when you're building a modern web app these days, you have a crucial question to answer, and that is, what is the rendering strategy your app is going to leverage? Are you going to do something that's more on the server side? Are you going to do something that's more on the client side? Or is it going to be some kind of hybrid combination approach? So we're going to take a look at different kind of rendering modes. And as you see on the screen here, there's all these acronyms. And I don't know about you, but when I see this, I sometimes feel like I'm drowning in this alphabet soup. And it's sometimes hard to keep track of what do these each mean, how do they differ, and again, what is the best strategy for my app? So that's what we're going to uncover in this talk. And we're going to start off by taking a brief history, looking at the history of web rendering, how we got where we are today, what are the modes available to us, and what is the best strategy for us. So we'll zoom back in time. We're going to go back to the date of 1993. Why that date? That was the date that I personally got a computer at my house. My dad was pretty tech savvy. I'm an elder millennial. So we got a computer at home. Pretty soon I was on that computer creating beautifully pixelated images on Microsoft Paint, playing beautifully pixelated games like Ski Free. Anyone remember that game? The Yeti chasing you down the mountain? Yeah, a few of you. Cool. So when I wasn't skiing down a slope, I was surfing. I was surfing the web. So when I wasn't, convincing my family to get off the phone to get on that dial-up internet, I was surfing the web and visiting pages such as early static websites on GeoCities and things like that. So that's the first rendering mode that we're going to take a look at, static. Now at their core, static sites were simple web pages consisting of fixed HTML sites. Every user who visited that page was served the exact same unchanging HTML. And while they look a lot different now with CSS and other libraries that can enhance them, they are still valid. They still serve a purpose for simple unchanging sites, maybe for a local small restaurant, for their homepage and menu, something like that. But of course, they are not ideal for dynamic data or a site that needs to be personalized based on who's using it and how they're using it. So I kept surfing the web, and of course, the web was evolving and started to be able to do things online that I used to do in person. So I could collect the latest series of the Animorphs or Goosebumps collection. Any Animorphs, Goosebumps fans in the audience? A couple of them. I checked. They had Dutch translations, so I figured they might be relevant here, but maybe a little more of an American book. But Amazon.com. It had, when it was launched, over 1 million pages with different books. Each page was part of that web application under a multi-page application. So that's the next rendering strategy we're going to reveal here. Now, like it sounds, a multi-page application consists of multiple pages accessible by their own URL, and then navigating between those are going to trigger a full-page refresh. Visiting one of those pages means you are requesting that data from the server. It is going to render it on the fly. In the context of early Amazon, that means it's going to cook up that page with the relevant book title, image, description, and so on. And then it's going to send it over to the client. And because each page is rendered on the server, it can have its own metadata, which means that MPAs are very SEO friendly. They also offer a pretty clear navigation experience, a predictable one, because every page triggers that full page refresh, so you're setting kind of a standard expectation for your users. You can also predictably scale in this way under an MPA. However, since every page request involved a full round trip to and from the server, this can lead to performance and navigation issues, or rather performance issues and navigation delays, and really just headaches for managing state across all of those different page loads. With this in mind, there are some scenarios where an MPA would be well suited. Those include things like large e-commerce sites with a large inventory of products, maybe a real estate or job listing sites, particularly with different entry points where users could be entering in from, maybe an administrative or governmental site that has a lot of different services under one hood. And there's many different applications for the MPA. In 2001, Wikipedia was launched, which is a perfect example of a classic MPA with a dedicated page per topic area. And this rendering strategy was going strong for bigger sites, and it wasn't until 2004 that we saw some real innovation with Gmail, who introduced the first big alternative, the SPA. Now, Gmail showcased the potential of creating dynamic, responsive, and really highly interactive web pages, and they did that through using JavaScript to handle the UI rendering and the client-side app logic. They also used Ajax for fetching data in the background. This eliminated the need for a full page reload, and it also allowed the user to receive real-time updates and navigate seamlessly around the app, all while maintaining application state within the client. Now, the introduction of the SPA was very timely because soon thereafter, in around 2008, we saw the introduction of both the iPhone, the Android, and their respective app stores. And this catapulted the native app revolution, and these apps featured seamless interactions with fluid animations. There was instant feedback with stateful interactions without any loading delays. And this really set a new standard for what users came to expect from their digital experiences. So, it wasn't a coincidence that soon after, major platforms such as Twitter began transitioning from being an MPA into being an SPA, therefore enhancing their user experience with a more dynamic interface. Now, if we take a closer look at how an SPA functions, it's really key to understand, which probably most of you know, what the term single page means and refers to, typically referring to the index.html file, and that is the app's entry point inside of which everything is loaded and rendered. And instead of doing those full page reloads, SPAs are going to enable the client-side navigation. So we have a lot more seamless, fluid transitions where the view changes, the components within that view change, but you're not triggering that full page reload. So we had a more native-like experience, again, which those mobile apps had accustomed digital users toward. But of course, SPAs aren't perfect. They do have some downsides because browsers do have to go ahead and download the entire bundle before rendering all the components. And this can result in damage to performance scores like your CLS and your LCP, especially if you're on a slower connection or if your user is on a less powerful device. And because everything is rendered on the client, your content cannot be crawled and indexed, so your SEO is going to suffer. You don't have those content previews for social media, etc. So understanding their pros and cons, SPAs are going to be particularly well suited for apps that are more dynamic, like a dashboard, an analytics tool, maybe certain kinds of social networks, and interactive productivity apps as well would be well suited for the SPA. Now, as the use cases expanded for SPAs, we saw the introduction of SPA frameworks. The first major one was Angular, which came out in 2010. This offered, really for the first time, a library that made it easier for developers to create and manage those dynamic SPAs without all the complexity and without all of the boilerplate and complexity under the hood. This was followed up in 2013 by Facebook with React. And pretty immediately, we then saw major platforms like Instagram, Airbnb, and Netflix adopt this library and approach. And exactly 10 years ago, as of this month, February of 2014, we saw Evan-You release Vue.js, which is why we are all here today. And this was rapidly adopted by its own major sites as well, like Alibaba, Xiaomi, and then later GitLab. And while all these frameworks are and were still enormously impactful, there was an increasing demand for faster loading, SEO-optimized sites, along with a more efficient developer experience for managing complex apps, and ideally with less boilerplate. And this spurred the development of meta frameworks, frameworks like Next for React and Nuxt for Vue. Now, these supplement their underlying libraries and automate away common tasks and boilerplate, and really provide some built-in performance optimizations as well. Now, taking a deeper look at Nuxt.js's rendering modes, it's still possible to create a SPA with Nuxt, and you would get some additional benefits from that meta framework. But really, a common reason developers choose Nuxt is to overcome challenges related to SEO and performance by leveraging its built-in support for alternative rendering strategies such as SSR or server-side rendering. So with SSR, if we take a look at how it's functioning, the browser is going to request the page from the server, which builds that page, including fetching any required data for that page, and then sends that fully rendered HTML back to the browser. And it's going to include a JavaScript bundle, and that will include all the necessary logic for that page. So once it's all received by the client, that JavaScript bundle is downloaded, and hydration occurs. This really means that the JavaScript is executed, event handlers are attached to the page, and it really becomes fully interactive. So things like button clicks, form submissions, page transitions, those all start working. So in essence, hydration is that step that transforms the server-rendered static page into a dynamic application in the browser. And this is what we call a universal app, because technically it's functioning both on the server and the client. It's also known as isomorphic because it has those two lanes of existence. Now, right after my talk, as you can see, Alexander is going to go much deeper and in much more nuance in the topic of hydration. So we'll put a pin in this for now on this topic, because he's going to take it from here. Now, with an SSR, because you can move dependencies and data fetching onto your server, you can achieve a faster initial page load. This is going to have improved performance scores and an overall smaller client-side JavaScript bundle size. And then crucially, search engines can effectively crawl your website, index your pages, and improve the SEO of your site. Simultaneously, it's going to make those social sharing previews possible as well. Now, SSR is going to shine particularly where real-time content is key. For example, a breaking news site that is using SSR, that's going to be guaranteed to serve pretty much the latest published news to visitors of that page. Or a live sports site that's going to deliver scores pretty much instantaneously, so the action on the user's screen is going to match the action on the field. And for better or worse, e-commerce these days is not just about anonymously browsing products. So if you want to be tailoring that shopping experience to each visitor by quickly generating pages that reflect their preferences, search history, and behaviors, an SSR might be a good solution for that. But what if your site does not need to be so interactive or personalized? In these cases, meta frameworks like Nuxt allow us to use static site generation. As it sounds, static site generation is going to generate a static site for you. So you're essentially going to pre-build all the pages with a command like nuxt generate. And it'll spin up those HTML pages. And then those pages can be deployed to any web server or hosting service that are capable of serving static assets, including a CDN. And then you're going to benefit from the global distribution and performance optimizations of that. So then at request time, those pre-built pages are sent directly to the browser without any need for real-time page generation, and that's going to ensure fast load times and improved performance. But it is important to note that there is a main drawback to building a static site, where if you had a large site with many, many pages, this is going to incur a very long build time. So if you imagine if you were running a news site and you wanted to launch a breaking news story, but you had thousands of pages to build, you don't want to wait 30 minutes, an hour or more to be the last one out the gate with that breaking news. So with that in mind, SSG is best suited for very static sites like portfolio, landing pages, marketing pages, documentation sites, or blogs, particularly where those blogs have content that's is not changing so frequently. So touring these different rendering modes, you might be thinking, well, what if I have certain pages that would be really good as an SPA, while others would be good as maybe an SSG? Well, fortunately, with Nuxt 3, we can actually implement hybrid rendering modes. And these are going to have different caching rules per route. One such hybrid caching mode is SWR, or stale while revalidate. Now, this is not isolated or particular to Vue/Nuxt. It's a more common approach, but you can do it within Nuxt. You can kind of think of it as essentially SSG on demand, where a user is going to visit a page for the first time, and then that page is built and sent back, and then we're going to simultaneously store that built page in the cache. And there's two different ways to achieve SWR. It's either you're setting a time to live or you're not. So with no time to live, Nuxt is going to save the API response that was used for generating that first version of the page. And then on the next page visit, that cached HTML is sent over. And then only the API is called on those subsequent requests. And when a change is detected during such a request, the server returns a stale response and then regenerates new HTML in the background, which will then be served for that next response. So that is with no time to live set. Alternatively, you can do SWR with TTL. Love all these acronyms. So what we're doing there is essentially programming a timer, and that's going to reset the cache after a certain duration. So when that time is up, the page is going to be regenerated and cached in the background. We also have a very similar rendering approach to SWR, and that's ISR, or incremental static regeneration. So the rendering and caching behavior here is going to be very similar to SWR, except that we're able to add the response to the CDN cache. And if we look at it with no TTL set, the content is going to persist until the next deployment inside that CDN. However, it should be noted that this kind of behavior, it only currently works on the platforms that support it, and those are going to be presently Netlify or Vercel. We can also set a TTL, a kind of timer the countdown, and that's going to, with the TTL set, the response is cached on the CDN for a set duration and then regenerated in the background at that interval that you set, and it then replaces the cache. You should be aware, though, that you might have seen out in reading docs and articles and stuff that ISR is also possible with Next.js. But the major difference between Nuxt and Next with this approach is that in Next, all pages are actually generated first at build time. With Nuxt, a page is generated at request time and then cached and regenerated according to the TTL configuration you have. So now that we understand how all these caching modes work, let's look at how we might set up a route rule-based rendering strategy for an app. Let's say we have a home page that would be great as a statically generated page. Our admin dashboard could function well as an SPA, while our blog utilizes incremental static regeneration. Within our Nux config file, we can set that up. So we can set up route rules to achieve this, where pre-render true, that's going to set up our home page to be pre-rendered at build time. SSR false, that's going to tell our dashboard to only render client side. And then ISR 3600, that is going to inform the page to be generated on demand and then regenerated every hour on the hour. Also, this is a note from the docs that if you're doing hybrid rendering, that's actually not available to you if you pre-built your whole site as an SSG with Nux Generate. So you either generate it all as an SSG or you decide to do this hybrid route-based rendering approach. So I kind of alluded to a bit with Next.js. So how does this compare to rendering strategies available in other frameworks? We're not going to go super deep because I only have a few minutes left, but if we look at Next.js, we'll see that it has essentially the same rendering modes that are available in Next.js, but as I alluded to, the implementation details are going to vary subtly. But what we're looking at here, this is more so in the Pages router version of Next.js. In Next.js 13, there was the release of the app router, and these rendering modes are still available to us, but essentially the concepts have been simplified, where we have server components and client components. So if we want a component to be a client component, we'd put use client at the top of it, and that would be essentially client only. It'd function as an SPA page, whereas server components are going to be the default, and their rendering strategy is actually automatically chosen by Next.js, and it's going to look at things within the file, like the presence of maybe get server-side props for real-time data, or get static props for pre-built pages, and configure that rendering strategy automatically. In Next, you can render client components for the parts of your UI that need to be interactive, which rely on things like state, lifecycle hooks, browser APIs, or React class components. Then the remaining components can all be your server components. When we look at Next with React's suspense component, pages can actually be broken into chunks, and these chunks can then be progressively sent from the server to the client. This is going to effectively stream the UI from the server as it's available, and that allows the user to interact with the page, or rather the parts of the page that are ready before it's completely loaded. And this component-based rendering strategy that Next.js is leveraging, it's not the only place we're seeing this approach. In 2021, we saw the introduction of Astro, and I'm calling this a Neo framework here. It's basically a framework, but why I'm saying Neo is because it uniquely is able to, allows us to create an app by fusing components from various different frameworks, such as Vue plus React plus Angular, etc. Astro has helped popularize the idea of islands, and these islands are going to be the sections of the app that receive JavaScript hydration. In other words, a component-based hydration approach. As I mentioned, you can compose an Astro app with components from various major frameworks, and then you can use client directives on there to control how those components, how and when those components are hydrated on that page. But Astro is not the only framework using this island concept, because Nuxt is providing the experimental Nuxt island component. That's essentially a server component in the Next.js way of looking at things. However, this is going to be inverted. In Nuxt, an island is the non-interactive component without any JavaScript hydration, which, if you think about it, I personally think that actually makes more sense as a naming convention, because if it's not hydrated, it's dry, it's sandy, it's an island, whereas if it's hydrated, it's wet, so it's the water. So that's just me. I think it makes a little more sense. So now that we're inundated with knowledge about the different rendering modes, how do we choose the best one for our next app? A decent approach is to ask yourself a series of questions, the first of which is SEO important? If yes, then you probably don't want an SPA. You can ask yourself, how often is my app going to update? If it's minute by minute, you probably don't want an SSG, SWR, or ISR. If it's hourly, an SSG would also not be very efficient for you. You can ask yourself how you want to host it. If you have static hosting in mind, you will want to avoid SSR, SWR, and ISR. And then finally, is first load performance important to you? If so, you would probably want to avoid an SSR as well as an SPA. In my use case, for ViewMastery, we're a content site. Of course, SEO is going to be important. Updates are made on a weekly basis. And so I would probably go for an SSG because I want it to be statically hosted, and first load performance is important for me. Alternatively, I could do a hybrid approach. Maybe my dashboard is an SPA, and then I have an SSG or ISR, something like that, for my content pages. All right, so hopefully with that kind of preview, or tour rather, you have a better understanding of the rendering modes that are available to you and what's a better fit for you. I also wanted to end with an exciting announcement. So if you've been coming to these conferences for a number of years like we have, you'll know that ViewMastery has been supporting open source and giving back on a monthly basis to the Vue.js framework. We've been doing that since 2017. And so as of this month, our exciting announcement is we have given a total of $800,000 to the Vue.js framework. That includes money directly into the libraries, the maintainers, and the authors of Vue.js, so we can support its sustainability and make it a beautiful, sustainable technology we can all use and love to use now and into the future. So if you've ever been a ViewMastery subscriber, I want to thank you because you've helped make that possible. If you want to join us and help make that number even higher, we have team accounts. You can join as a team, and those you would get a 55% bundled discount. And then also we have a 50% discount right now for individual subscriptions. So we'd love to have you on board and have you supporting open source with us. So with that, I thank you for your attention. Hope you have a good rest of your conference, and I'll see you maybe at the booth. We have available over there cheat sheets and stickers for you to take advantage of. All right, take care.